Alright, in this example, we are considering this function 3x plus 12 over x squared, where x cannot be 0 because that would create an asymptote, can't divide by 0 here. First, we're going to differentiate or find the derivative of the function with respect to x. One of the things I would first have a look at is bringing this power up so that we can use the power rule. X to the 2 on the bottom doesn't allow us to use the power rule too much, so we use our indices. That's the same as x to the negative 2. Now we can simply take the derivative, and that's 3. Power comes down, multiplies the coefficient, minus 24, x power reduces by 1. Alright, so the derivative is 3 minus 24 x to the negative 3. In part B, we need to calculate the derivative when x equals 1. So we're going to put, instead of an x, we put a 1. We're evaluating it in the derivative. So we use 3 minus 24 times 1 to the power of negative 3. 1 to any power is 1. 3 minus 24 is negative 21. In part C, we are asked to use this answer to decide whether the function is increasing or decreasing. Well, this gives us a slope of negative 21, so we know that the tangent line, slope of a tangent line, which indicates that the function is decreasing because the derivative has a negative value at that point. Now we are going to solve where the derivative is equal to 0. So we take the derivative, 3 minus 24. I'm going to rewrite it as over x to the power of 3 is equal to 0. All right? This allows me to first add this to the other side. So 3 equals 24 over x cubed. Now just doing a little bit of algebra, multiply by x cubed, divide by 3. We get x cubed equals 24 over 3. X cubed equals 24 over 3 is 8. Now we need the cube root of both sides. Cube root of 8 is 2. All right? So the equation where the derivative is equal to 0 has a slope of 0 is at x equals 2. Carrying on, the graph has a local minimum. If it has a minimum, that means it has a slope of 0 at exactly that point, at point P. All right? Let t be the tangent to the graph. So now t is going to be the equation of a tangent line at this point P. All right? So write down the coordinates of P. Well, we know from what we've done that at x equals 2, we have a tangent line of 0, a slope of 0. So that could be our local minimum. We could also graph this in our calculator and have a look and find that minimum. But let's use our result from before. We'll put 2 into this function. 3 times 2 is 6. Plus 12 over 2 squared. 2 squared is 4. 12 divided by 4 is 3. So 6 plus 3 is 9. All right? So f of 2 was equal to 9. So the coordinates are 2, 9. All right? Putting 2 into the original function and evaluating. Write down the gradient. Now it gets a little bit easier again. Write down the gradient of t. Well, the gradient of the tangent line is, of course, 0. Then it says the equation of t. Well, a horizontal line with a slope of 0 will have y equals as a coordinate, as an equation. It goes through 9, so we know that y equals 9 is the result. All right. Next, we're asked to sketch the function from negative 3 to 6. Be careful of your window. From negative 7 to 15. Indicate clearly the point P that we've just talked about and any intercepts of the curve with the axes. All right. So in this situation, I would use my calculator, and I've put my equation into the calculator, the original equation of the function. I set my window exactly as the problem asks, and I graph it. All right. So to indicate to the person that's marking this that you clearly understand things, you need to clearly indicate your scale is what they asked for, and there is an x-intercept. Here is a minimum. So it says sketch the graph, indicate clearly the point P. Okay, this is my point P, and any intercepts of the curve with the axes, all right? So that is this point here. So let's have a look. And we are going to calculate the 0. We come over. To the left of the 0, press enter. Come over to the right of the 0, press enter. And we see negative 1.59. All right. So this point here also asks for negative 1.59. All right. So intercept, there is no y-intercept because x could not be 0 because of the asymptote. We do have one x-intercept. This curve comes up and down. We have a minimum. So we have indicated clearly our scale and any intercepts and the point P. All right. Draw and label next the tangent T. So let's draw the tangent T. The equation was y equals 9. So we take that right here. So y equals 9. This is the point 9. Okay. T intersects the graph at a second point. All right. Write down the x-coordinate of this point of intersection. Again, good use of the calculator here will help out. So we go, we graph y equals 9. We have a look at the picture, just like the sketch here in red. Now I want this point here. So I find the intersection. I come over, so I don't find the first one. I want this second one. Keep coming. Eventually we'll see the cursor. And on a Casio, this is even easier because it finds it right away. There, x equals -1. All right. So the x-coordinate of that second point is x equals -1. Let's write that a bit more clear. X equals -1. All right. So T intersects the graph at the second point. Write down the x-coordinate, not the coordinates, but the x-coordinate of the point of intersection. X equals -1. Good. And that about wraps it up.